Today, let's take a look at how we can write a program in C++ and make use of classes. Classes allow us to improve code readability. It binds data to its proper code, and it prevents you from misusing your code. So there's a lot of good advantages to using classes. At first they may appear more difficult, but actually once you see them a couple times it's pretty straightforward and easy. So to start with, we're going to say File, and we're going to File, New, Project. I typed in a path name and then I typed in a name of the project, and then be sure to click here where it says C++ executable project. I'm going to use the ATmega328P. So in this example, I'm going to make a class that refers to the ADD converter. The basic template for the class will look like this, where before the main you would say something like class, name of the class. In this case, the name of my class is called A to D, and then I have a curly bracket to curly bracket, and inside of here will go the data and the code for this class. So I'm going to start with private, and then I come down to public, and in the public area will be all the code that you can use in the main program. So down in the main program here, this can run any of the public subroutines, but none of the private stuff. That's why they call it private versus public. The public area here can call anything in the private area. The reason for having the private area is so that code or data in private is kept away from the programmer in the main program. We don't want the main program to have access to the private subroutines or data, because at that time the programmer should not be using that code. But to get to that code, the programmer would call the public subroutines, and those would in turn access the private. Well, next, as you can see, I have added a line of code to the private section, and this is a subroutine called init, and it will do the DIDR0 setup for the ADD converter to the proper number. But this subroutine called init cannot be called from the main program, but it could be called from here within the public area. Next, in the main program, I'm going to make a variable called A to D, right there, and it is of type A to D. So the first one is the type, it's a class, and the second is the variable, and it's the instance of the class. So remember, the AD is the instance of the class of the variable, while right before it is the type of variable. When A to D is created, or I should say when AD is created, that will come up here to the public area and find its constructor. The constructor has the same name as the class. So the class is called A to D, the constructor is called A to D, and this constructor will run the init, which is up here. So once again, when you make a variable, that variable will then execute the constructor. In this case, it is here, and that constructor will run this, which is up here. So this causes this to occur, which then comes up here, which causes that to occur. Well, I typed in the rest of the code. That should work well. For the class, once again, we have the constructor, which is this subroutine right up here. The constructor is the same name as the class. Also in the public area, I have another subroutine called get. It returns an integer, and it will return the ADCH value from the ADD converter. We send to the subroutine, though, the channel that we want to talk to, like channel 0, 1, 2, 3, or 4, maybe 5. That channel number adds to 20 base 16, and that goes into AD mux. Again, that will select the channel 0 through 5. The ADC SRA will be set to this number, and this allows us to enable the ADD converter, start the ADD converter, do it one time only, and also to enable the ISR for the ADD converter. The ADD converter will start to work at this point, and it will finish when it makes the conversion. But we must wait. How long to wait? Well, what we're going to do here is we're going to say that done is false. We will loop while the done is false. And when the converter is finished, the interrupt service routine will then kick in when the interrupt finishes. So when it finishes, this line kicks in down here, and the ADD converter becomes, the ADD done variable is set to a true when the converter finishes. So after this point, it comes back to where it was in the while statement. The while statement will then say, okay, I'm done, and it will stop looping. And at that point, we will return the ADCH value to where we came from. Now, in the main program, we first made a variable called AD, and then we say AD.get. Notice it's AD.get. It's that variable dot that subroutine. We're going to run that subroutine, and we're going to pass to it a number 0, which is the channel 0. It gets a value, puts it back into X. It then runs the similar code, but this time we're going to send a 1 into the get, and it will then get channel 1. That will go into Y. At this point, we could use X or Y to graph something or do some other stuff, but I'm not going to do anything at this point. Just end the program. By the way, this variable called ADCDone is a volatile global integer way up here, and it is set to the value 0. It needs to be volatile and global. Okay, so you see here is an example of how to work with a class. The class has a name. It's just an idea. It has a private and a public section. The public subroutines can be executed from the main program, whereas the private subroutines can only be executed from the public area and not from the main program. So we tend to put all the data and code that shouldn't be touched by the main program, we put that in the private area. Another good example besides an ADD converter might be an LCD screen. With an LCD screen, we have just a few subroutines that are public, but we have a lot of private code that we should never ever touch. And the private code works with all the details, and those details we don't want to see in the main program. We want to hide those details in the private area. We want to hide it because we don't want to touch it, mess with it, or look at it, or use it. Okay, so this again is how we can construct a class.